For Learning Target 11, Day 2, we're going to take a look at some more solving proportions, this time with a variable in the denominator. Now, there's an easy fix, and there's actually two different ways you can look at this. I chose to go the route where you can just flip the fractions. And then your variable is no longer in the denominator, and you can solve the proportion like normal. Now, think about it this way. I've got 2/3 equals 6 over something. If I had 2/3 equals 6/9, because 2 times 3 equals 6, and 3 times 3 equals 9, what would happen if I flipped those ratios? What would happen if I had 3 over 2 equals 9 over 6? Would that still be true? Well, yeah, because 3 times 3 is still 9, and 3 times 2 is still 6. So I'm going to flip the ratios, like I said, to get 3/2 equals n over 6. We already solved this one. That was my example that I just used. Notice the pattern that 2 times 3 equals 6. And whatever you do to one part of the fraction, you've got to do to the other. So if I take 3 times 3, I'm going to solve for n. Now, if that didn't make sense to you, let me show you another way to get the same answer. The way that we solved the proportion before, and I'm going to reset up my proportion, was by multiplying by the denominator, following the golden rule. So if I multiply both sides by 6 to cancel my 6 over here, on the left-hand side, 6 divided by 2 is 3, and 3 times 3 equals 9. But what I would like you to do is notice this relationship that I pointed out here. That if a number in both denominators or a number in both numerators is the same, you can just follow that pattern. Let's take a look at another one. I'm noticing a pattern on this one. It doesn't even matter that the variable is in the denominator, so I'm going to actually ignore my steps on this one and show you 3 times 3 gives us 9. So g times 3 equals 10. So to solve this equation, I'm going to divide both sides by 3, and g equals 10/3. Alright, so now we're going to take a look at binomials in the denominator. This works the same way, except for I'm seeing this pattern again. I don't think I intended to do this on all of them, but I don't need to get my w out of the denominator because 4 times 4 gives us 16. So 10 times 4 equals w minus 8. 10 times 4 equals 40. To solve for my w, I will add 8 to both sides. W equals 48. Alright, on this one, if I try and find some sort of relationship from -2 to -3, doesn't go in there evenly. So let's take a look at this process again. If you've got a variable in the denominator, you flip the ratios so that your variable is no longer in the denominator. So my first ratio becomes d plus 9 over -2, and my second ratio becomes 4d plus 1 over -3. And then you will solve the proportion. The way that we solve the proportions, remember, is to cancel the denominator. So in this case, we're going to have to cancel one denominator at a time. So I'm going to start by canceling my -2. Now remember, whatever you do to one side, you do to the other side. So on the left-hand side, my -2's cancel, leaving me with d plus 9. And on the right-hand side, I must distribute that -2. Now remember, I'm not multiplying by -2 over -2. I'm multiplying by -2 over 1. So I'm going to distribute that -2 to my numerator, not my denominator. So we got -8d minus 2 over -3. So now I'm going to cancel my -3 by multiplying both sides by -3. So the entire left-hand side of the equation will be multiplied by -3. On the right-hand side, the reason I multiplied was to cancel, so I'm left with -8d minus 2. On the right, I will distribute -3d minus 27. And to solve for d, I'm going to get my d's together. Now negative 8 is smaller than negative 3, so I'm going to cancel my d's by adding 8d to both sides. On the right hand side it cancels, leaving me with a negative 2. On the right hand side I get a positive 5d minus 27. So to finish solving I'll add 27 to both sides, canceling on the left hand side. Now if I borrowed $2 and I earned 27, once I pay back my debt, I still have $25. Dividing both sides by 5, d equals 5. And your U-try problems.